everyone, this video will show how to change two intercepts form equation of a line to its equivalent point slope form. So what's going on here is that we're given the two intercepts form of a line and we are going to transform it to its equivalent point slope form. Before we go further, please feel free to check out the description below for the link of the other series of topics related to linear equation. Before we go over some examples, let's have a review on the basic information about the two intercepts form of a line and the point slope form of a line. So if we are given two intercepts of the line, that is 0b, which is our y-intercept, and a 0 as our x-intercepts, we can use the formula x over a plus y over b equals 1, where again our a is the x-intercept and the b is the y-intercept. This is called the two-intercept form of a line or the double-intercept form of a line. So if we are given the slope of a line and a point, we label this as x1, y1. We can go ahead and determine the equation of this line by using the formula y minus y sub 1 equals m quantity x minus x sub 1, where our m is the slope and the coordinates x sub 1, y sub 1 is a point on the line. Sometimes the slope is not given, but another point is given. We can go ahead and solve for the slope of the line using these 2 points, and we still can use the point slope form. We just have to pick which of those 2 points we use to replace the y1 and x1 in the equation. Okay, going back to the example right here, so we're given this two intercepts form of a line, and again, we're supposed to determine its equivalent point slope form. The first step that we're going to do is to change this to its equivalent slope intercept form. So I'm going to go ahead and write this given two intercepts form down here. In order that we can change this to its equivalent slope-intercept form, we are going to multiply these two denominators here. Whatever that product is, we're going to multiply both sides of the equation by that product. So 2 times 3 is 6. So I'm going to multiply this by 6, and I will multiply the right side by 6 as well. So we go ahead and distribute this 6 to each of the terms inside the parentheses, and this would come out, that's going to be 6x over 2 plus 6y over 3 equals 6. Again, I got the 6 by multiplying 2 times 3, and that is 6. So we go ahead and simplify this further. That's going to be 6 divided by 2 is 3, and that is 3x plus 6y divided by 3 is 2y is equal to 6. So this is the standard form of this two intercepts form right there, but we wanted it in slope intercept form, so I'm going to go ahead and isolate y by itself here. So I'm going to subtract 3x from both sides minus 3x. So then this would come out, we can cross the 3x out, so we're left with 2y equals negative 3x plus 6. Then we are going to divide both sides by 2 so that we can isolate y by itself. So then our slope-intercept version of that two intercepts form right there would be y equals negative 3 over 2x plus 3. So again, this is our slope-intercept form for that two intercept form right there. So I'm going to go ahead and write that down here. Okay, in this problem, again, we are not supposed to come up with the slope-intercept form. However, we're supposed to come up with a point-slope form. So what are we going to do here is that we are going to break this 3 into two numbers such that if we add these two numbers, it will come out 3. So then we can go ahead and say that this equation that we have right here would come out to this form. So I can rewrite this as y equals negative 3 over 2x plus, I need to come up with two numbers such that if I add it, it's equal to 3. So I can have 2 plus 1. So 2 plus 1 is 3. So then we can go ahead and distribute this plus or positive to both terms inside the parentheses. And so our equation would come out y equals negative 3 over 2x plus 2 plus 1. So that we can go ahead and come up with two equivalent equations from here. We can either subtract 2 from both sides, or we can subtract 1 from both sides. So I'm going to go ahead and rewrite this equation down here. So in this side, I am going to subtract 2 from both sides. So this would be minus 2, and this is minus 2 right here. And so our equation would come out. That's going to be y minus 2 equals negative 3 halves x plus 1. Now we are going to isolate this slope right here. So this would come out y minus 2 equals, isolating it, that's negative 3 over 2x plus 1. The trick is we are going to multiply this constant here by the reciprocal of the slope. So that would be multiplied by negative 2 over 3. And so our equation would come out. That's going to be y minus 2 equals negative 3 halves. And that would be x minus 1 times negative 2/3 is negative 2/3. This tells us that 2/3 comma positive 2 is on the line. So I'm going to go ahead and label that down here. So this is the equivalent point-slope form of this equation that we have up there. So we go ahead and come up with another equivalent point-slope form. This time around, we are going to subtract 1 from both sides instead of subtracting 2. So I'm going to go ahead and show the work down here. So this is another equivalent point-slope form of this two intercepts form that we have right there. So these 4 equations that we have here, this two intercepts form, this slope-intercept form that we have here, and this 2-point slope form that we have here are all equivalent, meaning if we graph all these 4, they will be the same line. So I'm going to go ahead and say that our 4/3 comma positive 1 is on the line. So I'm going to go ahead and label that down here. Now what about if we are going to put a minus instead of a plus here, so that it will still come up plus 3. So I'm going to go ahead and show another equivalent point-slope form to this two intercepts form right there. So what I'm talking about here is that if I am going to come up this equation as y equals negative 3 over 2 x minus, that would be, let's take 6 minus 9. 6 minus 9 is negative 3. So negative of negative 3 makes it a positive 3. So that we can go ahead and simplify this by distributing the negative here to both terms inside the parentheses. So our equation would come out y equals negative 3 halves x minus 6 plus 9. Now that makes sense because if you have negative 6 plus 9 is positive 3. So then I'm just expanding this 3 here. So what's going on right now is that we can come up with infinite number of possibilities such that when we add or subtract 2 numbers, it will come out 3. So that these are just one of those combinations. Again, you can have infinite combinations here. So from here, we can go ahead and come up with another 2 equivalent equations. It's either we're going to add 6 to both sides or we're going to subtract 9 to both sides. So I'm going to go ahead and show the work on the side right here. So on this side, I am going to add 6 to both sides. And on this side, I am going to subtract 9 from both sides. So I'm going to show the work down here. So this is another equivalent point-slope form of this two intercepts form that we have up there. So I'm going to go ahead and show the work when I will subtract 9 from both sides. And this is another equivalent point slope form. So if you notice, we already have come up with 4 equivalent point slope form of this given two intercepts form that we have right there. That means that if we are going to graph all these 4 equations that we have here, it's just the same line. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!